Hello everyone, I'm Satvika Reddy. I'm currently pursuing my first year BTech in the Institute of Aeronautical Engineering in Computer Science Engineering AIML branch. The topic is Eulerian circuits and planar graph properties and applications. Now let's discuss the topic. What is Eulerian circuit? An Eulerian circuit or Eulerian cycle is a closed path in a graph that starts and ends at the same vertex, travels along every edge exactly once, does not repeat any edge through vertices can repeat, and they exist only under specific degree of conditions. These circuits have powerful applications in network design, urban planning, and circuit layout. Eulerian path visits every edge once but doesn't necessarily return to the start. Eulerian circuit visits every edge once and returns to the starting vertex. Also, it has to have an even degree. Then only we can call it as Eulerian circuit. What is a planar graph? A planar graph is a graph that can be drawn on a flat plane like a paper without any edge crossing each other. Each enclosed region, including the outer region, is called a face of the planar graph. A planar graph can be drawn on a plane without any edge crossing. For such graph, Eulerian circuits have these key properties. Degree conditions. A connected planar graph has Eulerian circuit if and only if every vertex has an even degree. Phase traversal. In planar graphs, Eulerian circuits can be used to traverse the boundaries of the faces, regions enclosed by the edges. Dual graphs. The dual of the planar Eulerian graph is also Eulerian under certain conditions, which is useful in the topographical theory. How to identify an Eulerian circuit? To determine if a planar graph has an Eulerian circuit, we have two conditions. The first one is check connectivity, and the second one is check vertex degrees. So, check connectivity. The graph must be connected. If it is not connected, then it is not an Eulerian circuit. Check vertex degrees. Every vertex must have an even degree. If it doesn't have even degree, then it is called as Eulerian path, but not an Eulerian circuit. Eulerian circuits in planar graphs. An Eulerian circuit in a planar graph is a closed trial that visits every edge exactly once in a planar graph. So, it is simply an Eulerian circuit that can be drawn on a plane without overlaps. Applications. The first application is about urban planning and route optimization. Use it to design street sweeping, garbage collection, and postal delivery routes where each street, that is urge, must be covered exactly once. The second application is about computer networking. Helps in network traversal and data packet rotating where each connection must be used once without repetition. Use it in the design water and electro networks that CC connection once. Route planning. Applied in the postal garbage collection and street cleaning. Each road, that means urge, must be visited once. And the third application is circuit designs. In VLSI designs, planar Illuria circuits helps optimize wire routing on circuit borders to minimize crossing and the overlaps. And the fourth application is DNA sequencing or bioinformatics. Eulerian paths are used in bioinformatics for genome assembly, especially in the diverging graphs, which are often planar. DNA fragments are modulates as edges. Eulerian path helps reconstruct original sequences. And the fifth application is graph drawing and visualization. useful in graph layout algorithms that aim to minimize edge crossing and improve readability. And the other applications like robotic and path planning, robots use Eulerian circuits to clean or inspect every line or path once, like vacuum robots. Then the seventh one is computer graphics. User in algorithms that draw figures without lifting the pen. Draw this shape in one stroke. Then it is called as Eulerian circuit. Then theoretical insights. Eulerian formula for planar graphs. V minus E plus F is equals to 2, where V is vertex, E is edge, and F is face. This relation helps check whether a given graph is a planar or not. The next slide is about expanded properties of Eulerian circuit in planar graphs. Here are more advanced properties. Phase traversal and duality. In a planar embedding, Eulerian circuits can be used to traverse the boundaries of the phases. The dual graph of a planar Eulerian graph is also Eulerian if every E phase in the original graph is bounded by a even number of degrees or edges. Real life examples. The bridge were represented as a planar graph. Each landmass is equals to vertex. Each bridge is equals to edge. It's about the 7 bridges of Kongensberg. The bridges were represented as a planar graph. Each landmass is equals to vertex. Each bridge is equals to edge. 4 vertices have odd degrees. No Eulerian circuits possible. Eulerian proved this in 1736, the first result in the graph theory. This is why Eulerian circuits are named after him. And the next slide is about edge coloring. Eulerian planar graphs often allow edge coloring with fewer colors due to their even degree structure. This is useful in scheduling and resource allocation problems. The next slide is about cycle decomposition. Any Eulerian graph can be decomposed into a set of edge disjoint cycles. In planar graph, these cycles can correspond to phase boundaries or routing loops. Here is an example of a graph. This is the original graph choosing the edge AD, and the circuit so far is AD because it's a joint graph. It doesn't disjoin any other vertex. And the next is AD is deleted now. D is the current. Can't choose DC since that would disjoint graph choosing DE. Circuit so far is ADE. E is current. From here, there is only one option. So the rest of the circuit is determined. Then the circuit is ADE BDCA. Let's go into a quick recall. First definition. What is Eulerian circuit? A closed trial visiting every edge exactly once, drawn without edge choosings. And the conditions for the graph is connected and all vertices have even edge. If it doesn't have, then it is called as Eulerian path. And the formula V minus E plus F is equals to is the formula. Dual graph bipartite in original Eulerian. Examples square, hexagon, planar roadmap, and the applications. route design, circuit design, robotics network, inspection, map coloring. In simple words, an Eulerian circuit is a planar graph, is a continuous path that covers every connection once, returns to the start, and can be drawn neatly on a flat surface without any edge crossing. It exists only when every vertex has an even number of connections and the graph is connected. Thank you.